All right, we're going to start by looking at what happens when we intersect two constructible lines. So remember, what it meant to be constructible was that the coefficients of the equation of the line were numbers. So again, F is a field of constructible numbers. And you should think about this as, for example, F is the set of rationals. And so our lines were constructible, coefficients were in that field of constructible numbers. So we might take the line a1x plus b1y plus c1 equals 0. And then our second line might be a2x plus b2y plus c2 equals 0. And these are constructible. Saying these are constructible means A1, A2, B1, B2, C1, C2, all are in the field F. So maybe all of them are rational numbers. So if I want to solve this system of equations, I do something where I want to solve for x and for y in terms of A and B and C. A-I, B-I, C-I. So I want to know what is x equal in terms of all those variables and what is y equal in terms of all those coefficients, I should say. And I'm going to leave you to try this algebra if you want to and just write down our answer. So our answer, if we do this solving, what we end up with is that x is b1c2 minus b2c1 over a1b2 minus a2b1. And that y, when we solve, ends up being a2c1 minus a1c2 over a1b2 minus a2b1. So this turns out to be our solution. And what we want to notice here is that f was a field, right? So all of our coefficients, all the a's and b's and c's were in a field. And so when we find what x equals and what y equals, fields are closed under addition and subtraction and multiplication and division. So notice that the point x, y, and I'm going to write this a little bit differently. Notice that x is in F and y is in F. All we've done is taken those coefficients that maybe are rational and we've combined them in this way, and what we end up with is another set of rational points. One other thing to note here is that this is only working if that denominator ratio isn't 0. If you got 0 there, if a1, b2 minus a2, b1 was 0, what it meant was that those two lines were parallel and they didn't intersect. And so that isn't really an issue for us. If the lines intersect, then this is the intersection point, and that will all be well defined. Okay. So x and y are in F, and so if we set two lines that have rational coefficients, what we learned is that the intersection point also has rational coefficients, which is kind of interesting. So that means when we took these that we knew we could construct, what we got was a point that we already knew we could construct. Okay, so the next video we'll do this thing with intersecting a line and a circle, and then we'll do the same thing intersecting two circles.